Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from May-June 2023, Paper 2 Variant Theory. In this lesson, we will discuss about mechanics questions. We will also talk about waves questions. We will also discuss about electricity and radioactivity. Simply speaking, we will try to finish all the remaining questions from this paper in today's lesson. In order to get maximum benefit from these videos, always do questions first of all by yourself and then compare your answers with my solutions and watch the video to improve your conceptual understanding. Let's study together, let's improve together. Question 3, part A says, state the principle of conservation of momentum. According to principle of conservation of momentum, momentum before any collision is equal to momentum after collision if no net external force acting on the system. No net external force acting on the system. Then momentum is conserved. So this is what we call is principle of conservation of momentum acting on the system. Means this conservation law is obeyed if no net external force is acting on the system in nature. Then momentum before is equal to momentum after. Now let me show you the answer, how you can write down your answer. So simply for the answer of this question, you can write down 1 point. Total momentum before is equal to total momentum after. This is M mark, means this has to be in your answer. And the second mark you will get if you have written if no resultant external force acts on the system, you will get A mark. So this is the A mark. In order to get A mark, you must get M mark, then you will get 2 marks. If you lost this mark, you will get 0 mark. Part B says a firework is initially stationary. It explodes into 3 segments A, B and C that move in a horizontal plane. Means all fragments that just move in horizontal plane. One goes like this, one goes horizontally and one go at a certain angle. So all of them, they are in the horizontal plane. And this view is given from the top, means if you're looking at them from above, we will see how these fragments, they will move in different directions, but they are in the same plane. Fragment A has a mass of 3m and moves away from the explosion at a speed of 4.0 meters per second. Fragment B has a mass of 2m and moves away from the explosion at a speed of 6.0 meters per second at right angles to direction of A. Means the angle between A and B is 90 degrees. Fragment C has a mass of m and moves away from the explosion at speed v at an angle theta as shown in figure 3.1. For part B1, we need to calculate value of angle theta. Beautiful question. This is about momentum in 2 dimensions. In 2 dimensions, mean in 2 directions. We can consider first of all this direction. So we can see momentum along this direction. Momentum along this direction has to be conserved, means momentum this side has to be equal to momentum this side. If you look at momentum of this one, momentum of this, it has momentum along horizontal, or simply we can say along x direction. We can just give names to them. We can say this is over x direction and we can say this is over y direction. Before we answer this question, we can resolve this one into 2 components as well. So in this case, this has 1 component along y and it has 1 component along x. We can write down the momentum for this one. So it has mass m, so this has v sine of theta, and this is with angle, so this component of momentum is mv cosine of theta. Mv cosine of theta. So along x direction, first of all we can write down, or simply let's say along y direction first of all, along y direction, so we can say along y. Along y direction, fragment B has momentum, that is 6 times 2m. So this is vertically up, so this is 6. Not vertically up, means in the plane, this is into the page. So this is 6 times 2m. So this is, and this momentum, we can take this direction as positive. So this direction has to be this direction also we can take positive by conventions. Total momentum has to be 0 in any direction because initial momentum is equal to 0. So we have 6 times 2m. This one has to be minus, this momentum has to be negative because this is down, and the sum of these two, it has to be equal to 0. So this one has to be equal to 0. From here we can simply say this is 12m, that is equal to mv cosine of theta. It's a basic question, just you need to be clear how to approach this type of problems. So m we can cancel with m, so simply we left with v cosine of theta. This is equal to 12. We can say this is equation 1. Now simply we have to look at momentum along x direction. So we can say along x direction. So simply we can say along x direction. So this is along x direction. Along x we have momentum of this, so this momentum is positive. So we have 4 times 3, so we can say 4 times 3m, and this momentum has to be negative, means this one. So this is negative mv sine of theta, and this one has to be equal to 0. From here we can say this is 12m, that is equal to mv sine of theta. From here we can cancel m with m, so we left with 12. This is equal to v sine of theta. We can say this is the second equation. Now simply we can divide second by 1. So we have v sine of theta, this is equal to 12, divided by we have v cosine of theta, and here also we have 12. So from here we can cancel v with v, 12 with 12, so we left with sine over cosine. So this is tangent of theta, that is equal to 1. So from here we can write down theta, this is equal to tangent inverse of 1. So angle in this case will be equal to 45 degrees. So this is how we can answer a nice question about momentum in 2 dimensions. So this is how we can answer. This question has 3 marks. The first C mark you will get if you have written this equation, and the second C mark you will get if you have written the second equation, and the third mark is answer mark. If you have got the right answer, you will get 3 marks. For the second part, we need to calculate value of v, means we need to calculate magnitude of this velocity. In order to calculate magnitude of this velocity, we have 2 options. We can use conservation of momentum along x-axis, or we can use conservation of momentum along y-axis. So in this case we have this is x-axis, and we are assuming this one is over y-axis. So we will be using along x-axis, or simply we can use along y-axis as well. So let's use along y-axis. So we have this component of momentum, that is downwards, and we have another component of momentum that is to the left. So this is to the left, this is downward. So this is mv cosine of 45 degrees, because this angle we have just calculated, this is equal to 45 degrees. Now we can use conservation of momentum along y. You can also use along x, result is the same. Along y we have this is 6 times 2m, so this is equal to 12m. 12m is equal to mv cosine of 45 degrees. So m simply we can cancel with m. So v in this case is equal to 12 divided by cosine of 45 degrees. So our final answer is equal to 17 meters per second. So this is the answer up to SF. And this question has 2 marks. If you have written conservation of momentum, you will get 1 C mark, and if you have got the right answer, you will get 2 marks. Part C says the firework in B contains a chemical that has mass 5.0 grams and has chemical energy per unit mass that is equal to 700 joules per kg. It means if we have 1 kg of chemical, the energy is 700 joules. When the firework explodes, all of the chemical energy is transferred to kinetic energy of the fragments A, B and C. We need to show that total chemical energy of 5.0 grams is equal to 3.5 joules. For this question, simply we can write down 700 joules we have per kg, means energy per mass, and this ratio has to be equal to chemical energy, the amount of energy we have in 5.0 grams. We have 5.0 grams, so if we convert into kilograms, this will be equal to 0.005 kgs, 0.005 kgs. So we need to calculate this chemical energy. Ratio between these two is the same, because if more mass we have, it means more energy. If we have less mass, it means we have less energy. So it simply means that the ratio between these two is the same. So from here we can calculate chemical energy. So the chemical energy from here simply will be equal to 700 divided by 1 kg. Here we have 700 joules, and this has to be multiplied by 0.005 kgs. So kg cancel, and our final answer will be equal to 0.5 joules. So this is how you can calculate, and this question had just 1 mark. So if you have got the right answer, you will get this 1 mark. So this is how you can approach this part of the question. For the second part, we need to calculate mass m. In order to calculate mass m, we can use conservation of energy, because in the question it is given to us all chemical energy has been transferred to kinetic energy of fragments A, B and C. So we can write down E total, means the total energy, E total chemical, this is equal to KE total, total energy of all the fragments, and E total we have just calculated, that is equal to 3.5. So we can write down this is equal to 3.5 joules, and this is equal to the kinetic energy of all these fragments. So first of all, we can write down for m. So we have this is 1/2 m v square. The speed of this one we have calculated, speed is equal to 17. So we can say this is 17 square, plus we have 1/2 for 3m. So we can write down this is 3m, and the speed of this one is 4. This is 4 square. And now for 2m, we can write down this is 1/2. We have mass, that is 2m, and speed of this one is 6 square. Now if we solve this part, we will get 204m, and this is equal to 3.5. And from here we can find out m, that will be equal to 0.017 kgs up to 2 SF. So our final answer is 0.017 kgs. And this question has 3 marks. The first mark you will get if you have written conservation of energy, you will get 1 mark. And the second mark you will get if you have written these kinetic energies equation. And the final mark is the answer mark. If you have got the right answer, you will get 3 marks. Question 4, part A says, for a progressive wave, state what is meant by the frequency. For a progressive wave, simply we can define frequency is the number of wave fronts or number of crests, or you can say number of troughs passing a point per second. It simply means that if you look at a point and you count how many crests pass that point per second, that is the frequency. So let me show you how you can write down the answer. So this is how you can write down the answer for this question. So simply you can say the number of wave fronts, or you can say number of crests passing a fixed point per unit time. The beautiful way to observe this one is means how you can observe the frequency. You can look at the point and you can count how many crests pass that point in 1 second. So that is the frequency, how you can observe frequency of a progressive wave. For part B, it is given to us a loudspeaker, microphone and CRO are arranged as shown in the figure. So we have loudspeaker, we have microphone and we have CRO. The loudspeaker is emitting a sound wave which is detected by the microphone and displayed on the screen of the CRO as shown in figure 4.2. as shown in figure 4.2. So here we have figure 4.2. Time based setting for CRO is 0.5 milliseconds per centimeter and Y gain is 0.20 volts per centimeter. For part B1, we need to calculate the frequency of the sound wave. And from this figure, we can calculate the time period of the sound wave. So if you look at this one, we have 1 centimeter. So this long is equal to 1 centimeter. So it means one big square is equal to 2 centimeters. So we can say this is 0 centimeters, this will be 2 centimeters, this one will be 4 centimeters, and this one will be 6 centimeters, 8 centimeters, and this is 10 centimeters. So we have time period that is equal to 4 centimeters, and we have time base setting that is equal to 0.50 millisecond per centimeter. So from here we can calculate time period that will be equal to 2.0 times 10 to minus 3. This is millisecond, means 10 to minus 3. Now we can calculate frequency. Frequency is simply equal to 1 over time period. So we have 1 divided by 2.0 times 10 to minus 3. So the answer we will get in this case, that will be equal to 500 hertz. So this is the final answer. So we can say this is equal to 500 hertz. This question has 2 marks. The 1 mark you will get C mark if you have got right value of time period, and the second mark is the answer mark. If you have got the right answer, you will get 2 marks. For the second part, we need to calculate the amplitude of the signal received by CRO. In order to calculate amplitude of the signal, first of all, we can draw the equilibrium position here. And amplitude in this case simply is equal to this. Amplitude is equal to this one. And if we count these small squares, we will have 10 here. So we have 11, 12, 13, 14. So we have 14 small square. We can say 14 boxes. We can say small boxes, 14 small boxes. And 1 box, because 1 centimeter is equal to 5 boxes. So the 1 box is equal to 0.2 centimeters per box. From here, if we multiply this one, box will be cancelled. So 14 times 2, 28 divided by 10. So this is equal to 2.8 centimeters. Now we need to calculate amplitude. Amplitude has to be in volts. So we have 2.8 centimeters multiplied by Y setting, Y gain. Y gain is equal to 0.20 volts per centimeter. Now if we multiply this one, we will get our answer in this case, that will be equal to 0.56 volts. So the final answer is 0.56 volts. And this question has only 1 mark. So if you have got the right answer, you will get 1 mark, and this is the answer mark. Part C says the intensity of a sound wave in B is reduced to a quarter of its original intensity without a change in frequency. Assume that the amplitude of the signal received by the CRO is proportional to the amplitude of the sound wave. On figure 4.2, sketch the trace that is now seen on the screen of the CRO. For this question, it is given to us that intensity, original intensity, we can assume, let's say, is I naught, and the new intensity is I new, and I new is equal to I naught by 4. And for this question, we have to sketch the graph, so we need value of new amplitude. And also we need to understand that I naught, this is equal to K times A square, amplitude square. So from here we can say that I naught over A naught square, this has to be equal to I new, means the ratio has to be the same, over A new square. We can also write down I new in form of I naught. So this is I naught divided by 4. So here we have, this is A new square. From here simply we can cancel I naught with I naughts. So we left with A new square. That is equal to A naught square divided by 4. Means multiply by 1 by 4. So it means divided by 4. And if we take square root on both sides, so we can take square root on both sides. So we will get here, this is A new. And square root of this one will be A naught divided by 2. And A naught we have already calculated in the last part, that was equal to 2.8 centimeters divided by 2. So it means A new is equal to 1.4 centimeters. And in this case, frequency does not change. So the new wave also has the same time period. But amplitude is equal to 1.4 centimeters. 1.4. So this is equal to 2.8. So these are 14 boxes, small square. So new wave should have 7 SS, 7 small squares. Maximum amplitude means the maximum displacement, that is equal to amplitude. So 7. So we have 10. So 8. This is 9, 8, 7. So we can mark here. Here 7. So this is 9, 8, 7. We can mark here, and 7 here. So we 10, 9, 8, 7, and here we have 10, 9, 8, 7. So we can mark these points. So we have 10. So this is 9, 8. Here we have 7, and here we have 10. This is 9. This is 8. This one is 7. Now simply we need to connect these points, and we can sketch. So let me show you how you can sketch in a nicer way. So this is how you need to sketch. Same time period, but amplitude is equal to 1.4 centimeters. So this is how you need to sketch. This question has 3 marks. The first mark you will get if you have drawn the wave with the same period, as the previous one. You will get 1 mark, and that is C mark. And the second mark you will get if you have drawn this wave but amplitude is smaller than 1.8 centimeters. You will get second mark, amplitude smaller than 1.8 centimeter. You will get 1 mark, and that is M mark. Any value, but has to be smaller than 1.8 centimeter. And the third mark you will get if the amplitude is equal to 1.4 centimeter exactly. You will get 3 marks. If you satisfy these two parts, these two conditions, you will get 2 marks. And if you have satisfied the last one as well, you will get full 3 marks. Part D says a metal sheet is now placed in front of the loudspeaker in B as shown in figure 4.3. A stationary wave is formed between the loudspeaker and the metal sheet. State the principle of superposition. Principle of superposition simply tells us when two waves meet, imagine that we have one pulse and another pulse is coming from the other side. Let's say this one is moving to the right and this pulse is moving to the left. Principle of superposition simply tells us how we will find the resultant displacement when these two waves they meet. So this is what we call is principle of superposition. Simply we have to add individual displacements of each pulse to get the amplitude, or we can simply say the displacement of resultant wave. So if these two waves they meet at this point, let's say the resultant wave will have displacement this one. So this is the supercrest, and this is the vector sum of the displacements of these individual waves. So this is what is principle of superposition. Now let me show you how you can write down your answer. So this is how you can write down your answer. In your answer you can mention these points. You can say when two or more waves meet at a point, resultant displacement is the sum of the individual displacements of each wave. So simply you will add vector sum. You will calculate the vector sum of individual waves to find the displacement of resultant wave. Vector sum. So we can simply say vector sum. Vector sum. So this is what we call is principle of superposition. Part 2 says the initial position of the microphone is such that the trace on the CRO has an amplitude minimum. It is now moved a distance of 1.05 meters away from the loudspeaker along the line joining the speaker and the metal sheet. As the microphone moves, it passes through 3 positions where the trace has an amplitude maximum before ending at a position where the trace has an amplitude minimum. Determine the wavelength of the sound wave. So for this question, first of all, it is given to us the microphone is at minima. So here is minima, and after minima there must be a maxima, then there will be minima, then there will be maxima, then there will be minima, then there will be maxima, and finally again we have minima. So we have three maxima. So these are three maxima. Now we can draw the standing wave between them. So we can draw the standing wave. So it's a nicer way. You can simply draw like this. So let me redraw this part. So we have stationary waves. So this is how stationary wave will look like. So this is the stationary wave. Now we need to understand the distance between two consecutive nodes. This is equal to lambda by 2, and between next two consecutive nodes this is also lambda by 2, and between next two consecutive node distance is also lambda by 2. So simply we can say in this case we have the distance that is equal to 3 lambda by 2, or simply we can say this is equal to 1.5 lambda, and the distance traveled by the microphone we have that is equal to 1.05, and this is equal to 1.5 times lambda. So the lambda from here we can find out that is equal to 1.05 divided by 1.5, and in this case we will get 0.70 meters up to 2 SF. And so this is how we can calculate value of wavelength. And this question has 2 marks. The first mark you will get if you have written this one. So you will get 1 C mark, and the final mark is the answer mark. If you have got the right answer, you will get 2 marks. Third part says use your answers in B1 and D2 to determine the speed of the sound in the air. In part B1 we have calculated frequency of the sound. Frequency was equal to 500 Hertz. And in part D2 we have calculated value of wavelength that is equal to 0.70 meters. Now we need to calculate speed. So V is equal to F times lambda. So simply plug in values and we can find the speed of the sound. Multiply by 0.70, and if we solve this one we will get 350 meters per second up to 2 SF. So this is our final answer, and this question has 2 marks. If you have written this formula you will get 1 C mark, and if you have got the right answer you will get 2 marks. Question 5 says a student sets up a circuit with a battery, an ammeter, a heater and a light dependent resistor all in series. The battery has negligible internal resistance. A voltmeter is connected across in parallel with the heater. For part A on figure 5.1, complete the circuit diagram of this arrangement. So pretty straightforward question. We need to connect all the components in series, and then we need to connect voltmeter in parallel with heater. So let me show you how you can quickly sketch this circuit. So this is how we can simply sketch this circuit. So we have ammeter that is in series, heater is in series, LDR is in series, and voltmeter is connected across heater. Part B says the heater is a wire made of metal of resistivity 1.1 times 10 to minus 6 ohms meter. The wire has length 2.0 meters and cross-sectional area of the wire is given that is equal to 3.8 times 10 to minus 7 meters square. The reading on the voltmeter is 4.8 volts. The resistance of the heater we need to calculate, and resistance of the heater simply we can calculate R is equal to rho L by A. We have value of resistivity that is equal to 1.1 times 10 to minus 6 ohms meter, and we have value of L that is equal to 2.0 meters, and we have cross-sectional area that is equal to 3.8 times 10 to minus 7. So if we do calculations, our final answer has to be equal to 5.8 ohms up to 2 SF. So this is our final answer. This question has 2 marks. 1 mark you will get if you have written this formula for using this formula, and the second mark you will get if you have got the right answer. So this is how these 2 marks will be awarded to you. For the second part, we need to calculate the reading on the ammeter. Before we answer this question, the main concept you need to understand. As in the circuit, all the components except voltmeter, they are connected in series. It means current passing through each component is the same. For this question, we have value of V across heater, that is equal to 4.8 volts, and also we have resistance of heater. R for heater we have that is equal to 5.8 ohms. So I simply is equal to V divided by R. So we have 4.8 divided by 5.8. So this is equal to 0.83 amps. And this question has only 1 mark, and that is the answer mark. If you got the right answer, you will get 1 mark. Part C says the heater is replaced by a new wire. The new wire is made of the same metal as the wire in B and has the same length but a larger diameter. The resistance of LDR remains constant. For part C1, state and explain whether the new wire has a resistance that is greater than, less than, are the same as that of the wire in B. So pretty straightforward question. For this question, it is given to us it is made of the same metal, same length, but diameter is larger. So simply we need to understand that R is equal to rho L by A. And from here we can see this is rho L divided by pi by 4d square. So we can simplify, we can write down this is 4 rho L by pi d square. Now for this question it is given to us that L is the same, rho is the same. If diameter increase, it means resistance will decrease. So the new wire has lower resistance. So that's all what we need to say for this question. This question has 2 marks. The first mark you will get if you have written A larger, means cross-sectional area is greater for new wire. So R is less than that of first wire. So if diameter increase, it means cross-sectional area also increase. Part 2 says state and explain whether the new reading on the voltmeter is greater than, less than, or equal to 4.8. So for this question, the resistance of this heater has been decreased. If resistance of this heater has been decreased, it means R total in the circuit has decreased. R total has been decreased. So it means I total in the circuit increases. If I total in the circuit increases, it also means that if we connect a voltmeter, let's say V1 across this LDR, resistance of LDR is not changing. So we can say V1, this one will be equal to I time resistance of LDR. As resistance of LDR is not changing, but current in the circuit has been increased, it means V1 will increase. If V1 increase, then V has to decrease because EMF is equal to V1 plus V, and EMF is constant. So if V1 increases, V has to decrease, means potential difference across heater, it has to decrease. So the V will be less than 4.8 volts. So these are the points you need to understand. First point you can say R total decreases. 1 point we can say. Second we can say current in the circuit increases. So voltmeter reading decreases. So we can say this is the third point. So these 3 points we can mention in our answer. So let me show you how you can write down the answer. So this is how you can write down the answer. First point we can say total resistance decreases, so current in the circuit increases. So PD across LDR increases, so we have mentioned PD across LDR increases. So this V1 increases, so hence voltmeter reading is less than 4.8. So if we write down these points, you will get 2 marks. So this is M mark, mean it has to be in your answer. PD across LDR increases, and then you need to write down voltmeter reading less than 4.8. You will get answer mark A1. Question 6 part A says define the Young modulus. Young modulus simply is equal to stress divided by strain. So simply we can say Y, this is equal to sigma divided by epsilon. Stress divided by strain is the ratio between these two quantities. So this is how you can write down your answer. If you write down stress divided by strain, you will get 1 mark, and this is B mark. Part B says a uniform wire is suspended from a fixed board. Masses are added to the other end of the wire as shown in figure 6.1, and graph between length of the wire and force is given to us, and cross-sectional area of the wire is given, that is equal to 0.95 millimeters square. We need to determine the unstretched length of the wire. Unstretched length of the wire means that we will have L naught when F is equal to 0, that value. So if you look at this point, we have force that is equal to 0 and the value of L we have. So this is 1.998 meters. And this question has only 1 mark, and that is the answer mark. Part 2 says for an applied force of 30 newtons, determine the stress in the wire. Stress in the wire when applied force is equal to 30 newtons. So we have value of applied force, and stress simply is equal to applied force means F divided by cross-sectional area. We have value of F that is equal to 30 newtons, and we have value of cross-sectional area that is equal to 9.5 millimeter square. So we can say 9.5 times 10 to minus 6 meters square. And if we solve this one, we will get 3.2 times 10 to 7 Pascal. So this is value of stress. For the second part, we need to calculate strain of the wire. Strain of the wire simply is equal to delta L. Delta L means the change in length divided by the original length. So in this case, we apply force of 30 newtons. So we have to take extension until this point. Means we have, this is the new value of L, and this is the original value of L. So we can calculate delta L. So this is 2.003 minus, we have 1.998 divided by L naught. L naught is 1.998, and if we solve this one, we will get our answer that is equal to 2.5 times 10 to minus 3, and it has no units because this is the ratio between two same quantities. So this is our answer, and this question has only 1 mark, and that is the answer mark. If you have got the right answer, you will get this mark. Question 7 part A says table 7.1 shows incomplete data for 3 flavors of quark. The elementary charge is E. Complete table 7.1 by inserting the missing charges. So we have up quark, down quark, and charm quark. We also have up anti-quark, down anti-quark, and charm anti-quark. So first of all, let's try to understand the charge on up quark and the charge on the charm quark. These two, they have the same charge, and the value of charge is plus 2 by 3 times E. And the charge on down quark is minus 1 over 3 E. But we also need to understand the charge on anti-quarks. Down anti-quark, the charge on this one is 1 over 3 E. Opposite charge, but magnitude is the same. And so same we can write down for up anti-quark, and we have charm anti-quark. They have the charge plus 2 by 3e, and these are anti-quarks, so the charge has opposite polarity. So if this is positive, this has to be negative, and vice versa is also true. So this is minus 2 by 3e. Now simply we need to insert these charges. Down quark charge is equal to 1 over 3 because E is already written there, and charm quark charge is 2 by 3, and we have up anti-quark, so this is minus 2 by 3. We have down anti-quark, this is plus 1 by 3. We have charm anti-quark, so this has to be minus 2 by 3. Means the quark and anti-quark, they must have opposite charge. So this is quark and this one is anti-quark. So here we have quark and this one is anti-quark, and they are multiples of elementary charge. Part B says using the symbols given in table 7.1 state a possible quark composition for the following hadrons. a neutral baryon. Neutral means it has no charge. Baryon means that it consists of three quarks, and the net charge has to be 0. So we can take one up quark, and if we add two down quarks, total charge will be equal to 0, because this has plus 2 by 3 and this is minus 1 by 3 minus 1 by 3, so the net charge will be equal to 0. Or we can say we take one charm quark and we add two down quarks. So in this case the net charge also will be equal to 0. So you can write down any one of them. And for the second part, we need to write down quark composition for a meson with a charge of plus E. And meson, it consists of quark and antiquark. Quark plus antiquark. It consists of two particles. One has to be quark and the other one has to be antiquark. So if we take, for example, one up quark, so the charge on up quark is plus 2 by 3e. And now we need to add another quark, so it become 1. So if we add one down antiquark, so we will have charge that is equal to plus E. So let me clear this one and let me write down for you. So we can say we have charge plus 2 by 3E plus we have 1 by 3E. So this is equal to plus E. We can also say we have one charm quark and we add one down antiquark. The total charge on this one is also equal to, means on this meson is also equal to plus E. Now if we go to part C says quarks are fundamental particles. Electrons are in another group of fundamental particles. Electrons, they belongs to lepton family. So they belongs to lepton family. For the second part, we need to state the name of another particle in this group, leptons. Leptons consist of electrons, muon and tau, and also their neutrinos. So we can write down electron, and the antiparticle of electron is a positron. We can write down positron, we can write down neutrino, so we can say neutrinos, and also we can say antineutrino. You just need to write one of them. You can say antineutrino. You can talk about muon. You can talk about tau. So you can say tau. You can even also talk about positron, because positron also belongs to same family. This is antiparticle of electron. So positron is also fundamental particle and it also belongs to lepton family. If this video was helpful, please like and subscribe, because your encouragement is very important. You can like, you can subscribe, you can also leave some comments in comment section, and also if you have any questions, you can also leave your question in comments. I will try to explain you as soon as possible. See you in next video.